worked with the team at Ford to establish, what are the baseline requirements for self-driving in navigation. And it turns out that meter level is not good enough. You need to know your position to like 10 centimeters. And for some context, 10 centimeters is the width of the paint on the road. Historically, there was maybe 1,500 satellites operational for all countries, all companies. But what could you do if you had access to thousands of satellites in low Earth orbit? There's really three big things we're trying to hit. So one is bringing centimeter level location out of the box. You're going to go from this kind of meter level location you get from GPS data down to centimeters. The next is resilience, bringing 100 times stronger signal to the end user. What that unlocks is it brings indoor locations. So it's no longer science fiction, it's actually there.
Tyler, thanks so much for being on the podcast today. First time it is you, Startup Fest studio, so appreciate you making the trek. I'm so excited for our conversation, man. I'm going to geek out on so many things space. As I was telling before recording, I grew up as a Star Trek nerd. Maybe a little bit of background on yourself. How'd you get started in your career? And give us a little bit of the bio.
First of all, thank you for having me. It's great to be in this new space. We're just down the street in St. Henry, so we're neighbors in some sense. Like you, I'm a space nerd. So I also grew up nerding out on space. I remember the moment I became interested in space. I was a kid at a sleepover watching Apollo 13. I don't know if you've seen this movie, still one of my favorite movies. And I remember watching this and being like, wait, that was real? We did this as a civilization? Yeah, that's what I'm going to do. And it just hit me at that point of, space is what I'm going to be focusing on. And that set me on this path to kind of where we are today and building satellites. And here we are today.
Obviously, I want to talk about Xona, but then maybe just how does one study to build a space cup? What do you have to learn?
I started in engineering, as a lot of folks do in this. And a lot of that was motivated by a lot of kids are like, I want to be an astronaut because these are the idols in space. These are the folks that are in the news. I remember when I was a kid, people like Julie Payette were on the front page of Journal Montréal. And so I went into engineering here at McGill in Montreal and studied, really got myself into any project that had anything to do with space. And so that's how I found my way into working through kind of projects on the Canadian Space Agency. So working on problems around orbital mechanics. So getting deep into the technology of how do the satellites work? What are the missions that are important for Canada? And then I found my way to the US in grad school to continue studying in places like SpaceX were just coming online at that time when I was starting at grad school, which is what drew me to somewhere like California to study more about this stuff.
How long did you live in California?
I was there for almost 10 years.
Oh, wow. Okay, yeah. Because then I saw that you're studying Stanford, you're a lecturer there, and you worked at Google for a bit, right?
I did, yes. Yeah. So I think we had in common that we were almost at Google at the same time. And I found there by way of being interested in space. But it was really the application of space that drew me into the topic of GPS and navigation, because I am not someone who knows inherently how to navigate the world. I'm directionally challenged. So right around the time that I got down to kind of San Francisco Bay Area, smartphones were becoming everywhere. And so I didn't have one yet, but I had friends who had one. And it was like, oh my gosh, there's a dot on your phone that shows you where you are and where to get to. That was a game changer for me because it really unlocks it takes away this fear of going and exploring. So if you don't know a place, you might be like, I'm not sure I really know how to get there. Maybe I won't go. But if you have this device, it's, sure, I'll go to a new city that I've never lived in before. Let's go and explore some new places. You can't get lost now. It's taken away that fear of getting lost. And so that drew me into this sort of application of space for Earth, being kind of GPS and navigation really coming together, of these things coming together in smartphones for the masses. And that was what drew me into that topic of GPS and navigation.
I think many people realize, I remember we're around the same age, and it's like, how big a shift that was. If you were driving before, I remember literally printing maps and you have to go to the US, print on your screen. And now with the smartphones, we're just so accustomed to it being everywhere, 5G, and you're able to get around. But I think the point you raised that's interesting is it creates this fascination of, there's a before and there's an after.
Yes.
Maybe to dive in, I know we're going to get to Xona, but GPS, my understanding, military in the 50s. Give us the history of GPS from your vantage point.
Yeah, one of the first things we did with satellites was navigation, because it's so important. It's really fundamental to what we do. Where you are, what time it is, these are things very connected in this world of navigation. The first satellite navigation system came in the 1960s. This was in low Earth orbit, was the kind of thing that was built for submarines, ships at sea. You get a position every hour, something like that. It would take you 15 minutes of watching the satellite go overhead to get something. That was the state of the art until the 90s. But they needed something better. They needed something that would work with airplanes. They needed something that was higher accuracy. They needed something that would work more globally, more real time. And that was the birth of GPS. And so GPS, as you mentioned, is fundamentally, it's a military system. So it was built around military requirements. And very famously in the GPS program office, there was 3 things on the wall for the folks working on the program. It was drop 5 bombs in the same hole. So that was driving the requirements of accuracy and bunker busting. Make a cheap receiver set that navigates. So don't make the user equipment too big or too complicated. And the third one was don't forget it, which is this very like military. Don't you forget that the first 2 things are the thing. So it's a very simple mandate, but it resulted in this GPS system, which came online. The first satellites were launched in the 1970s. So they made a lot of very modern decisions around that system and anticipating where the market would go. One of those big things was just digital signals. So they chose waveforms that were very digital in nature, not analog as things were before. That meant that the receivers had to be good at doing digital signal processing, which took a lot of compute power to do that. But they were banking on Moore's law, catching up to things in coming years. So the first GPS receivers were the things that would be on a battleship, but now it's in everybody's pocket.
How did it move beyond military to commercial? Because, and maybe that's a good segue to then talk about what you guys are trying to do. Because my understanding is like, obviously it was in the realm of states, right? That can only do this. But at one point, like you said, in the 90s, I believe, like how did that happen?
It was, so they always built the system around, part of the way that they justified building the system and spending this much money on it was that there would always be a civilian use case for the system. But they sold a system that one day there might be 30,000 users of GPS in the civilian world. Now that number is billions, and 99% of users of GPS are civilian users. And the way that it was constructed is that there's a civilian part of the service and there's a restricted military part of the service. And so initially the civilian service was intentionally degraded, which meaning that if you were using GPS, you would know your position to 100 meters, half a kilometer, something like that. So this is helpful if you're like hiking or something like that, or roughly trying to get to where you're getting to. But if you're trying to navigate on the street, it's not going to work for that because it's going to tell you you're in Montreal. It's not going to tell you what street you're on to do your turn-by-turn navigation. And that was true until 2000. And that's the way the system was. But it was seen that there was so much utility in having that sort of more widespread for the civilian community. And this was actually, in some sense, sparked by some events that had happened in the world around aircraft straying into the wrong airspace because their navigation systems weren't working well. And it was like, don't we have this GPS system? Why aren't people just using it? A plane got shot down for no reason. We should just open this up to the world. And it was funny, in May of 2000, you see the system go from 100 meters of air to like snapping down to 1 meter. And that same year, you start to see turn-by-turn navigation units from Garmin, Tom, this kind of those early things that were in cars to do that.
Yeah, it's fascinating. Now, I'm going to go back to you're in California. You discovered I really the history that you provided. How did you then decide to like, okay, I know how you spoke about, okay, wanting to study this. How did you then think, okay, there's an opportunity and come up with a little bit of the embryo of the idea behind Xona?
So I'll start by saying I was never a startup person. I think there are some folks that their ethos is to go out there and just be a startup and build something from scratch and do something new. I am a more conservative person by nature. My friends will tell you that. And I studied civil aviation safety. So this is like the safest thing you could study in some sense. But something interesting happened when I was in grad school, this was around kind of 2015, 2016, where there was announcements for all these new satellite constellations going up. So historically, there was maybe 1,500 satellites operational for all countries, all companies, everything collected together, 1,500. It's really not that many. You consider there's 10,000 flights a day. There's not that many things in space that are really all of GPS, all the communication satellites, all the Earth observation satellites. It's 1,500 is not that big a number. So when there was this announcement of, hey, we're going to start launching constellations of thousands of satellites, we're talking about putting up whole constellations that are as big as the number of satellites in space. So this is that order of magnitude shift in deploying of number of satellites. So I convinced my advisor, hey, let me look at this problem of what could we do with commercial satellites in GPS? We have these systems that are up from government entities, so GPS from the US, Galileo from Europe, and Beidou from China, and the GLONASS from Russia. But what could you do if you had access to thousands of satellites in low Earth orbit? And so I wrote my PhD dissertation on this. And the interesting thing is that there's a lot of interesting trade-offs you could do of, hey, you can get GPS performance at a much lower cost, or you could get higher performance and it wouldn't come at a substantially higher cost. So there was some trades you could do of number of satellites, higher performance, all these things. But then as someone who wasn't working in the industry of where the needs were in navigation, I'm guessing as a graduate student, like many graduate students, you put on the shelf and you figure out how to get out and graduate and get out in the world. And the motivation really came when I started working in industry. So you mentioned I had spent some time at Google and Ford. It was really working at these places that I saw that real need for this.
What was the unlock? Was it the fact that technologically we can launch many more satellites, so that would enable a new form of GPS? Or is there something else in the tech stack like that enabled us to have like what you guys are trying to do essentially, this technology breakthrough?
It's both, is the short answer. I think that the technology has come to a point where it's available. So you can make GPS signals. There used to be this thing that was very complicated to do. Making digital waveforms, GPS-like signals, was the kind of thing only the kind of Lockheed Martins of the world could do. But now a 14-year-old could do it in their bedroom. And this is coming from the advent of software-defined radios. So more software-defined hardware allows for that flexibility. It's really out there. And part of what unlocked this a little bit was there's famously this game, Pokemon Go, which is this location-based game. And when you put getting Pokemon and points and location between the hacker community, you get low-cost GPS spoofers. And now you can, with some open source code, a software-defined radio from Amazon, you can make fake GPS signals in your dorm room that will convince your phone into thinking it's in Antarctica or anywhere else in the world under the guise of winning this game of Pokemon Go. But that kind of hardware unlocks these kind of opportunities. And you could put that same kit effectively into a satellite and now start generating something really interesting for the community.
Okay, so that's how the embryo of Xona came. Maybe it's a good time to talk about what is Xona.
Sure. So I think that and to give a little bit more of the kind of commercial motivation for Xona, because there's a lot you could do with that technology, but what is the right set of things to do for the industry? And that unlock for me really came from working in industry. So when I finished grad school, I worked at Ford Motor Company in Palo Alto, and this was their Silicon Valley branch of Ford. It was very much around autonomous driving. So this was the hot topic in kind of 2017, 2018 when I joined. And my job at Ford was to do technology scouting. So I was looking at location-based technologies, become familiar with the landscape. How does it fit into the autonomous stack? What are the right technology areas for Ford to invest in? And so I had this great education of just many startups coming in, pitching it to Ford. This is their technology stack. This is the performance. It was a lot of, how can I say? It was a lot of solutions looking for a problem. So it was a lot of folks that were like, we can do this kind of accuracy and this kind of thing. That's good for you. And there was not just the startup community trying to solve this, but also the established tech companies too. So those who had worked in building GPS technologies for decades, really trying to figure out what was the right solution for autonomous driving. And so they all kept coming to us saying, okay, what are the requirements for self-driving? What do you need as a self-driving car to do this job well? And so we didn't have a good answer to that. And I worked with the team at Ford to establish what are the baseline requirements for self-driving in navigation. And it turns out that meter level is not good enough. You need to know your position until 10 centimeters to a very high percentage of availability. And for some context, 10 centimeters is the width of the paint on the road. And so to do that job well and to for this to be safe, that's the kind of numbers we're talking about. And the startup community and even the established technology players were just miles away from that number. And so that's what started to drive this. What could we do in this space? It got my wheels turning of, if you had these low Earth orbit satellites and you could do something interesting, what would you do? And that started that process of starting to get into what could you do to help solve this problem from an infrastructure standpoint. Because I think a lot of folks were trying to shove more sensors into these vehicles. And what that ends up doing is making a vehicle that's $1 million. And it's a really expensive and hard thing to make. But if you can offload that to infrastructure that services the larger community, that starts to make this more viable. And so that's what really started that first step towards what became Xona.
Yeah. And if I maybe simplify that, so what Xona is trying to solve for is this down to the centimeter alternative to GPS. And I'm not sure if you're going to brand it something else. Like maybe you should have a different brand, which enables, like you said today, to go back to self-driving, right? There's two main modes, right? It's let's say the Tesla approach with the cameras or the Waymo approach with like expensive LiDAR.
Right.
But none of these cars talk to each other. So it's like, what this can unlock is we can't even quite imagine yet all the different use cases if you have down to this level of precision, right? How do you then go with this idea of, okay, crap, I need to build a company. Did you go ahead, set out and find a co-founder and then maybe walk us through the first few years of building Xona?
So the process was, as all these startups were coming in, there was this, I had this exposure to, okay, what are folks getting funding for? Because they would come in and say, hey, we just raised $10 million to do something interesting. And there were so many of those coming in. And I remember there was one company in particular, which I won't name, that had pivoted so many times trying to figure out where their tech would even fit. And it was interesting to just see how much money was being thrown at all these companies that just had the buzzword of autonomous driving in their pitch. And I just remember thinking to myself, I know a really smart group of people from grad school that we happen to have a very close-knit sort of friend group out of Stanford. And it was like, I think we could do something interesting here. Not trying to belittle the things that the other folks were doing, but if that was more of a realization of, okay, that's the bar. I think we at least can hit that bar. Let's go and try it. And so the way that it started was I put together a pitch. I pitched to my close friends, that many of which had gone and worked in industry. So I deliberately picked some folks who are in the satellite industry that were building satellites to try to assess how crazy that was. Folks in other industries that were consumers of navigation. So other self-driving car folks that were like trying to figure out solutions themselves. And then folks who were just experts in the kind of GPS technology stack. How do you build the signals? What should that look like? Is that kind of technology even feasible? And so what that turned into was a group of folks that, as long as I kept buying pizza, they would come to my apartment in the evenings. And when you get a bunch of folks that are fresh out of grad school, they're willing to do that for free food. And then we really got momentum when we got a business perspective on this. And Brian Manning, who's one of the co-founders of the group, who joined us maybe a month after we started doing this, happened to be doing an MBA, and he was fresh out of SpaceX at the time too. So he had this great combination of industry experience and drive. And it was when he needed a project in business school to sink his teeth into, that's when we really hit the accelerator and it became real.
Yeah. And like, I've had the benefit of talking to you guys and visiting your office. The vision for me, to hear it for you, but if I simply explain, it's going to be this new way for every single device anywhere on the planet to communicate. Walk us through a little bit of like, how is that going to happen? You have to basically piggyback on SpaceX launches, and maybe just walk us like how I know we're still early. It feels like early in your journey. At the same time, the tech is there, right? So yeah, walk us through if that's okay.
Yeah, there's really three big things we're trying to hit in terms of new things for the user that they don't have access to today. So one is bringing centimeter level location out of the box. So right out of the satellite, if you're using it, connecting to it, you're going to go from this kind of meter level location you get from GPS data down to centimeters. And so that's 2 orders of magnitude change. The next is resilience. And so resilience is quantified potentially a few different ways, but in our definition, it's stronger signal power. And so this is bringing 100 times stronger signal to the end user. What that unlocks is it brings indoor location. So it brings those signals indoors to help you navigate where you are inside. The big use case there today is things like Internet of Things. Is the package inside the building or outside the building? Because today they have no GPS inside. And so having something there unlocks a lot for them. And the third one really is security. Security is GPS is something that's unsecure today for the civilian users, which makes it's not authenticated, it's not encrypted. And what that means is that it's easy to spoof and it's easy to fake. And so this use case of 14-year-old with the spoofer in their dorm room with being able to trick a smartphone into thinking it's somewhere like Antarctica, that's fine if you're trying to cheat at Pokemon Go, but you can start to think of more nefarious use cases of that. What we've seen is that since the time we started Xona in 2019 till now, there's a lot of conflict arise in the world too. So places like Ukraine and the Middle East, and now we see widespread GPS jamming and spoofing happening. What that means is that is disrupting the civilian community too. So flights now in Europe anecdotally have to reroute because they're affected by the jamming in Ukraine, because we're talking hundreds of kilometers outside the border of Ukraine, up through the sky into space, everything being jammed in that region. And so this kind of resilience to jamming is a big deal for the civilian community. And you can imagine the defense community is interested in that as well. But the actual question you asked was, how do you go about building a system like this? Because it's an infrastructure system that is putting satellites up, operating them, and delivering a service from space. So in many ways, it looks and feels like GPS. And that's on purpose because we want it to be familiar to folks using it today so that it's not some new complicated thing they have to do. We want it to be literally like, all right, the thing you buy today, you buy the same thing. So the same receiver, the same hardware. That now just did a step change from doing GPS and maybe some of the other constellations to now GPS plus Xona. That means you have to choose the radio bands, the frequency bands, so that the same hardware can use it. So the same antenna, the same radio front ends, the same tuning, all that stuff. It fits into that same receiver without having to add a whole bunch of new hardware to make it more complicated and more expensive. So there's a regulatory element to coordinating the frequency space on that, which, by the way, we're the first commercial company to have gotten permission to operate in the GNSS band. So that was a historic first, which took a lot of people told us that would be impossible, as you can imagine. And you have to actually build the satellites and launch them. And so thankfully, one of the things that's opened up access to space is just there is more competition in launching. And there is also innovations happening, such as reusable launch vehicles like SpaceX. The analogy that's often used with SpaceX is that imagine how expensive a flight would be is at the end of every flight, you threw away the airplane. So you have seen that order of magnitude shift in cost of access, which means that you can consider things that aren't just these like small CubeSats anymore. You can put up big satellites for similar cost, and that unlocks a lot.
Yeah. And because you're not piggybacking on someone else's technology, that allows you, like you said, to really control end to end, right? There's notion of GPS spamming and spoofing. You're able to stop. Who's the first customer? Is it governments? Is it like commercial applications? Like how are you guys going to unlock for first customers an interest? Because I imagine military. Like feel free to not speak. And it's like I cannot say anything. But curious as to, because it feels like an endless opportunity. But then you obviously have to be very specific as to how you go after it.
It's a really good question, because I think one of the things you have to be careful with as a startup is you have to focus, because it's really easy to go after everything all at once. And although I use this autonomous driving use case as one of our early guiding lights, this is not going to be the early market for us, because automotive is a very risk-averse market. It takes time to integrate into those systems. What we found on this journey of Xona is, although we were developing a system that we thought would ultimately hit the needs of that use case of autonomous driving, we found that by hitting those marks, we were really attractive to a bunch of other industries that had a very real problem today, as opposed to a problem that's maybe 5 years away. The beachhead markets for us we generally have them in 4 categories. Defense is one. So defense and national security is one, for the reason I mentioned. Security and resilience to jamming, especially accessible in more mass market devices, is interesting. The timing market is actually a really big one. And so GPS, although we think of it as this positioning technology, it is just sending time signals from space. That's how we are able to do navigation, because the signal leaves the satellite. It takes a certain amount of time to get to you. That times the speed of light is the distance to the satellite. And that's how that whole system is architected. And so time transfer is one of the big use cases of GPS. So you can think of things like every cell tower, telecom, data centers, all these things rely on tight time synchronization, so they can interleave sending lots of data packets around. So that synchronization is very important. So when you think of infrastructure to power new technologies like AI, data centers are a big part of that, and time synchronization is a big part of how much throughput you can get through these systems. So the timing and infrastructure folks are probably one of the big early markets for us, frankly.
Yeah. Yeah, it's fascinating. You mentioned a question of focus, and I know and you guys just recently raised, it's been a few months now, but your Series B, 92 million. So congrats.
Thank you.
How much do you I know it's a classic investor question. It's of course, it's a huge opportunity, but now that you're in it, what's your viewpoint on how big Xona can get? I imagine eventually, is this going to replace all GPS? How do you see it?
I think we're a ways from replacing the government systems. I think that the way we see it for now is that we're a strong complement to those systems, because the government infrastructure, it's trusted, it's a baseline, it's never going away, at least today. And it's really this really strong backbone of all of this stuff in the community. And there's really an entrenched user base of these things. There are 7 billion devices that use GNSS today. That's more users than the internet and Facebook. So this is a really entrenched technology. There's a lot of these devices that are deployed for 10 years or more at a time. So it's really hard to turn that system off anytime soon. But there is a community that's looking for more than what GPS provides today. And I think that's where the opportunity is for us. So more accuracy, more jamming resilience, more security. And so that's where a complement from our system, which is in a different orbital regime. So to take a step back, GPS is at a 20,000 kilometer altitude in what we call medium Earth orbit. We call it medium because we generally put satellites in 2 places. We put them in a geosynchronous orbit, which is all the way out at 35,000 kilometers away. We put them there because that stays lockstep with the Earth. So basically, when you look in the sky, it basically is always in the same place. It rotates at the same rate that the Earth does. So satellite TV, this kind of stuff, those things that you point a dish at once and it stays there. It's always in that part of the sky. That's an example of a geo. And then we put stuff in LEO. So low Earth orbit is from 0 to 1,500 kilometers. Really 400 to 1,500 kilometers. And that's where a lot of Earth observation is. Medium Earth orbit is just halfway in between those two. And that's where we've historically put the navigation systems. And so another reason we're a complement is we bring diversity in the orbit of the system. So we're targeting a low Earth orbit system where we've already deployed satellites today. And there are many reasons for that, but one of them is to bring that diversity to the system, because medium Earth orbit brings certain characteristics. Low Earth orbit brings some new elements, different geometry. Geometry is super important for positioning because it's all about geometry. And so that diversity is another key thing that the LEO element brings.
Yeah, that's fascinating. It's like I was doing my research, I was like trying to understand all these acronyms of Leo and everything.
Oh, yes.
I was like, but if, yeah, like going back to, I guess, the essence of my question of how early it feels like it's definitely very early. Maybe I want to switch gears a little bit and talk about the company building side of it. And
Yep.
I'll start maybe locally because like I said, I visited your cool office. So
Thank you.
let's talk about your presence here. I know your headquarters is in California, but yeah, I'm curious as what are the people in Montreal building? And then also talk about your office itself.
Yeah. So yeah, as you mentioned, we're headquartered in San Francisco. I was down in San Francisco when we founded the company, but I've, being a Canadian, always envisioned bringing some of this element up to Canada. And we're very pleased that we're at that point now with the Series B and with the Series A before that to expand here in Montreal. And the focus of Montreal today has been around the user equipment side. So the receivers, this is the conduit to all these industries. So this also puts the focus of the product team in Montreal. At the end of the day, when we interface with these customers, what are the experience? How does this get into these various markets through the conduit of these receiver devices that receive and use the signal to actually do their job, whether it's navigation or timing. So all of that working with that hardware is happening here in Montreal. And then we work closely with our American colleagues who are today focused on the space segment and the actual building of the satellite and putting those pieces together. We work very closely together. We are a global system and a global company, so having a presence in multiple countries is advantageous in that region, for those reasons, because to operate the system in multiple places, there are lots of things you just need to figure out. So having that presence in 2 countries has helped us be ahead of the curve in that respect. And so in Montreal, we're happy to say we're growing. We're actually about to knock down the wall and take over the next few units. And to go back to your question of team building and how we got here, I think that, we have the benefit in Montreal of having a few years experience of things we can look to of what we did in the US, right and wrong, and copy some of those lessons. But we're still in that kind of, it feels like an early stage startup in Montreal because of the size of the team and where we're at.
Yeah, you definitely have that startup vibe when you visit. And yeah, so I guess the second part of the question was talking a little bit about that, the historic nature of that building. I just find it, I don't know if it was like on purpose, or I'll let you say the story, but I just find it's like such a great coincidence.
Yeah, I think that this is very serendipitous to your point. I'll say I'm a guy who likes history. And so I love the history in Montreal. I love things like the historic industrial corridor of the Lachine Canal, all the industries that were built there. Originally, we were looking at just old historic buildings that had a history of manufacturing because we would love to bring more of that element to Montreal over time. So we wanted to find a space we could be small and potentially grow into doing more hardware over time. And when we first reached out about the Nordelec building because it had this great, interesting history with Nortel and all these things. It actually did also work on some early communication satellites technology. It's a beautiful building if you've been there. And when he reached out about that, and I mentioned to the folks, hey, you're working in aerospace. And so I'm quoting the guys like, dude, you need to check out this other building because it's under construction. It has all this space history. And I'll admit, I was skeptical because I think I'm a space nerd. And when I heard that there's all this space history that I didn't know about in Montreal, I was like, that doesn't seem right. But I think it says a few things. One is that and there's an interesting museum in the building to learn about this. And I think it says a few things about Canada, which I'll come back to. But the interesting history of the building is that the first satellites in Canada were built there. But you go to this building, and thankfully now there's a museum, but there's nowhere in the building that highlights this. So there's not like a plaque on the wall or anything like that where it's Canada's first satellites were built here, all this crazy stuff. So it's this not forgotten secret, but you really have to be in the know to know that was a thing. And we've even had, just a few weeks ago, we had an astronaut, a Canadian Space Agency astronaut visit our office, Joshua Kutrick, which was a privilege and an honor. And we mentioned that Canada's first satellites were built here. And he's like, how is there not a plaque on the wall that says this? We should be celebrating this more. And it's just, it sort of feels like a miss that there's not like a more kind of raw history about it. So that's why I feel like it's my mission to go around celebrating this. But it's really cool to be in the building where, a lot of Canada's history in space started and being in the building, it feels like it wants to do more of it and do it again. So it's a good energy, I think, for us.
Yeah, you're condemned to succeed now. You have no choice.
We'll see.
You said before something I found funny. I'm not a startup guy, but I'm not a startup guy that's raised $100+ million. Any lessons? I'll say broadly, but it's either like things that you learn about like managing a team or managing a product, or also just maybe about yourself. Just curious of any insights now that you're like 6-7 years into the journey.
As I mentioned, don't consider myself fundamentally a startup guy, but looking back, I think there were some tells that maybe I secretly was one. I was a little academic, was a lot in the research domain, but there's a lot of that's just, you're doing a job where no one can tell you what to do. You can study whatever you want, work whatever you want, work in small teams. You have to be scrappy because you don't have a lot of money to build projects. So there's a lot of elements that are similar. And my wife, who's in academia, there's a lot of parallels that we have between building a company and building a lab. And so I think that there's something interesting there. But I think it's also, for me, being mission driven, I think really is a big factor. So although I had always said I'm not a startup guy, I remember with some of my close friends being like, if I were to do a startup, it would be because I felt really passionate about something that if I didn't do it, no one else would do it. And that's, I think, what we're doing with Xona it was this thing where it's not going to happen on its own. So someone needs to make this happen. And I need to quit my job and do it. There's no other way about it. It was just being driven to do it in that way. And so I think having that anchor point of it needs to be done, it has to be done, and no one else is going to do it but you, it puts you in the hot seat to figure it out. It just puts you in the hot seat to figure it out and to rally people around you to figure it out too. Yeah.
It's pretty inspiring because I think about what you guys are doing. It's so hard to predict the insane ways this is going to create so much good in the world, right? Like it's going to save lives in ways that we don't comprehend, right? And just make our lives easier, right? So I want to say hats off and keep building. So maybe last part of the conversation, I know we spoke about before, is that we do have to geek out on space. But I find it's one of the things now, like the science fiction stuff is, okay, we're going to literally send people to Mars before the end of the decade. We're talking about building a base on the moon soon and like all these crazy things so you're in the industry, right? So like how much of this is hype? What are the stuff you're excited about? Maybe stuff that no one's talking about, or maybe we are.
I think what's exciting is just the order of magnitude shifts that we've seen in the last 10 years. So we've seen launch costs go down by a factor of 10, roughly, I'm rounding. We've seen the number of competition in launch go up by a lot too. There's a lot of companies. We saw Blue Origin launch yesterday, right?
Yesterday. They did their official like reusable rocket, which is, I think even Elon was congratulating them. So
it's awesome. Yeah. We're now in a world where there's multiple companies that have this paradigm of reusability in rocketry, and that it's just more competition is good for folks like us that are trying to put stuff up because and I think that unlock brings about an ecosystem of access to space. And when you have that kind of access to space, it brings new players in that would never even dreamed of doing it before. And I think that before, I think folks who were trying to do things in space were thinking of this in terms of launch is so expensive. What can we do with a satellite that's like this big, the size of a loaf of bread? You don't have to think like that anymore. And I think we're seeing, bigger satellites being thought up and what can you do with big satellites in space? And that's where there's that other order of magnitude with that sort of lower cost of access to space. You can just put big satellites up now, and big satellites are what are powering things like Starlink. And you could put up a lot of them too. So that other order of magnitude is just the number of satellites that are being built now. These used to be these kind of one-off, bespoke, highly precious things. It costs so much money to launch it. We have to be really sure that it works. We can't have any failures. So there's that mindset of failure is not an option. So you can't have that level of iteration where you can launch something and if it breaks, so what? You have to have this mindset of, okay, everything has to be perfect and tested, and it means that you launch something in 5 years from now instead of 2 years from now, maybe. And so what that unlocks is this ability to put things up, try stuff, get things up quicker to iterate over, because that kind of hardware iteration, I think, is huge in just getting it right. But having some failures along the way is important, but I think the new paradigm lets you do that. And I think that ecosystem of where we used to have 1,500 satellites collectively as a civilization, and the largest constellation at that time was 66 satellites. That was the Iridium constellation, this kind of satellite phone constellation. Starlink launches 66 satellites at a time now to fill up their constellations of thousands and thousands of satellites, which are deployed at this point. So all these changes have led to just an ecosystem where there are more parts off the shelf for folks like us to go out and be like, hey, we want to build a satellite. Now there's an ecosystem of parts that are suited for that are built in a more automotive, high volume type situation. So they're cheaper instead of this kind of one-off. You make 1 or 2 a year. So you have to cover your margins by being really expensive, 6-figure devices. When you add up 10 of those, you're at millions of dollars per satellite. We're entering a phase where those order of magnitude are changing. So it's just exciting.
Yeah. You mentioned the cost of launch going down by order of magnitude, and it keeps going down, right? Kudos to SpaceX obviously leading that. But I find what's interesting is that it unlocks all this the space economy in essence, right? Like even lately has been talk about like let's shove data centers up there because it's super cold. So we needed to think about cooling it down and going back to being able to drop down the signal quickly, back to satellites. So are there any use cases outside of Xona? So stuff that you're like, oh, this is like geeky cool, going on the edge here, but curious if you have any things that you're curious about.
I think that one of the things, just for example, one thing I'm excited about, just because I'm a nerd about these things, is going back to the moon, for example. We went from an era in the 1960s where we were going regularly to the moon, and then we lost that ability over time. So just getting back to the point where we were before, to regain some of that knowledge and getting back to being able to flex in space like we used to is, I think, really exciting because it brings about, I think, new challenges, which, I mean, we saw in the Apollo program, just there were so many weird things that you had to solve that it just resulted in a bunch of new technology and technology transfer to the kind of, to the rest of us that were silly things like Velcro and other things like that. But I think that putting ourselves in a position where there are hard problems to solve, and by going to places like the moon, which kind of forces us to solve some of these new problems, I think it's just a really interesting time to see. And it's cool to see in one of the next Artemis mission, have a Canadian astronaut on that as well. So first Canadian going to the moon. So I think that's it's just a highlight of the exciting times ahead.
Yeah, no, it's pretty cool. And it's, I know we're talking a lot about Mars before as well, but the moon's a bit closer.
Yes.
Maybe we start with the moon.
Start with the moon. Yeah, I think it's a good place to start. I think I would rather see us actually get to the moon in short order as a stepping stone to get to Mars and relearn some of the things that.
Yeah. Can we then launch from there to get to Mars?
Why not? Yeah. I'm probably the wrong person to ask. Yeah. Why not?
I was going to say, I want to go back to Xona for a bit. Yeah, what's been the hardest part in doing this? It feels B2B SaaS. Yes. And then you guys are like, okay, we're going to build satellites. Like hardware is immensely difficult. What's been the biggest challenge you faced in the journey?
I think we've been very fortunate to have a good team. And so when you have good people around you, I think some of the hard times become easier. I think that there's been two big challenges that I have faced, at least. One is building hardware is hard, and it takes time. It takes more time than you think and takes more money than you think. So it is a capital intensive thing. So raising money and being on top of that to build the hardware, it just is a long haul. So you have to find the right investors who are on board for that kind of long haul hardware, deep tech, space tech, and be on board for, yeah, this is going to take a while, guys, and we understand that. So I think getting that right team in place that's a big factor. So you don't want to rush it. You don't want to just take someone that looks good on paper that maybe sounded good for a completely different company. You want to find folks that understand your mission, are on board with it, and build that team around it. And that's true in the investor community, but also internally with Xona as well. And the other is there's just challenge of trying to sell something that doesn't exist, which that's true everywhere, right? When you're an early company, you're trying to sell something you maybe haven't built yet. But with satellites, I think that the concept was at the point where a lot of folks were like, yeah, if you had this, we would definitely use it, but let us know when you have it. And before then, we're not going to sign something that says we're going to buy this from you. I'm not sure you're even going to launch one of these things, let alone like hundreds of them, because some folks they know it's going to take time to get there, and they want to see if we pass some tests first. And so you have this kind of chicken and the egg of, you need to prove to investors that there is a market, but at the same time, people in the market don't want to spend too much time on you because you don't have a satellite, or you don't have space infrastructure, or maybe they're skeptical that you're going to get something up. So there just is this grind that you have to get through before you have something in space that is working, which we're very happy to say we launched in June, and the satellite is hitting all those proof points now, and it allows us to engage with customers in a meaningful way, show the technology working with partners through the receiver side, and then showing it now with end customers in real use cases. So we had one of my colleagues was at a data center the other day showcasing time transfer capability from the satellite. And so it's no longer science fiction, it's actually there. But there is that period of, you just have to understand you got to hunker down and grind for a bit, because that's true in any startup, I think. But in space and tech, when there is a failure, there can be long periods of time before the next success. So you have to be able to weather the storm.
Vision and keep grinding.
Yeah.
Tyler, it's been a fantastic conversation. Maybe a last question. If people want to learn more about the journey, connect with you, send in their resume, what's the best way?
We just launched a new website, so I encourage folks to check it out, xonaspace.com. We would love to connect with folks in the community here. Although I'm from Montreal, a recent retransplant here. I've just moved back here 2 years ago, so would love to connect with folks in the community here. Just please ping me on LinkedIn. Happy to connect there.
Great. Thank you so much, Tyler.
Thank you.